Okay, so the first, you can write it down if you want to, but maybe just pay attention. Okay, that's probably the most important part. So I just want to talk about the test and some prompts to give you with the questions. So in the first one, you're going to have a data set, and it gets you to find, mean, median, mode, standard deviation, etc. Okay. Now, one way we're going to make sure you don't make any errors here is that we're going to give you one piece of data. Okay, so that when you put all of it in your calculator, Sam, Brad, that piece of data should match up with the one we give you here, okay? Because if you don't get the rest right, then you're going to get 0 marks. All right, we're going to tell you how you can get the right answer. It's just about putting the right numbers in the calculator. We've raised this point before, but I just want to remind you of it. Okay, we have positive skew, normal distribution, and negative skew. And in positive skew, right, the mode is smaller than the median, which is smaller than the mean. Okay. And in negative skew, we have the mode is largest, which is larger than the median, which is larger than the mean. Okay, so they go in that order. I just want to talk about how you can tell the difference between a normal distribution question and a binomial. Okay, so for a normal distribution question, you're going to be given a mean and a standard deviation. Okay, so if you're given a mean and a standard deviation, that means we're doing a normal distribution question. In a binomial, you're going to be given some number of trials. We're going to be repeating some experiment n times, and you're going to be given a probability. All right, probability of success or probability of failure. So that's how we can tell the difference between them. Just on the normal question in the test, okay, just so we don't get confused, it is about percentages. So what it is, it's talking about like a maths test or a maths exam or something like that. And it says, the mean result is like, I don't know, like 60%, and the standard deviation is 10%. Okay, so then you can fill in the table accordingly. So you're going to have 60%, 70%, 50%, etc. But don't confuse that with the percentages that are going to be in these regions as well. Okay, so there's sort of 2 percentage things going on there. And then the last thing I want to talk about is this sort of question here, okay? And we'll go through this example here. So we've got a raffle. There's 100 tickets, okay? And let's say we've got 5 tickets, okay? So we've got 5 tickets, and they're going to draw 2 tickets at random from the bucket because there's 2 prizes. So the first question is, well, what's the probability of winning both prizes? Okay, so that's a pretty simple calculation to do. The probability of winning the first prize is 5 out of 100. All right, pretty small. We've got 5 tickets out of 100 in total. And then it's conditional probability. We've won the first prize. What's the probability of us winning the second prize? Well, we've got 4 tickets left in the pool out of 99 tickets. Okay, so that'll be the calculation that we performed there. Okay, the probability of winning at least one prize. This is very difficult. That's why I'm going to go through it with you guys, so get a bit of preparation. Of winning at least one prize, because you'd be tempted to use a binomial distribution there, right? At least one, so you'd be BCD 1 to 2. The problem with that is we're not replacing the tickets. So the probability changes, so the binomial distribution does not hold. We can't use the binomial distribution. So instead what we should do is go, well, what's the probability of not winning a prize? Okay, let's figure that out first. What's the probability of not winning a prize? So on the first draw, all right, the probability of not winning a prize is 95 out of 100. Okay, because we have 5 tickets, 95 of them will not give us a prize. And then on the second draw, the probability of not winning a prize is going to be 94 out of 99, because we still have 5 tickets, and so then the other 94 are going to be tickets such that we don't get a prize. So this is the probability of us not winning a prize. And so then the probability of winning at least one prize is going to be 1, take away this calculation here. Alright, so that went a little bit tricky. So I'll talk quickly about that again. I think the first one's fine, that's just a conditional probability calculation. This one here, probability of winning at least one prize. We've said, well, we can't do that using BCD because the binomial distribution doesn't apply because the probability changes. So we do the inverse. We go, what's the probability of not winning a prize? Okay, so that's going to be this event here. And so then the probability of winning at least one prize, because the sum of all events is 1. All right, and so then we take away the event where we don't win a prize, leaves us with the probability of winning at least one prize. And there's a question that's pretty similar to this in the review sets as well. So that's pretty much all I want to talk about. I might come around and see how your revision's going. Test looks good. Thursday in here. Yeah.